So let's talk about some antiderivative rules in our integral calculus quick start guide. And the first most fundamental rule that we ever deal with in calculus integration is what we call the power rule, which we just ended in the last video talking about. It says that the antiderivative of x to the nth power times dx will always be 1 over n plus 1 times x raised to the power n plus 1 and a constant of integration. One note is that we should make sure that we avoid numbers like n equals -1. Why? So, as an example of this, it turns out that any time that we have x raised to a power, like x times dx, we treat this as x to the first times dx, and by the power rule that means n is 1, and so our integral would have to be 1 over 1 plus 1, x to the 1 plus 1th power plus a constant, or shortened a little bit, 1/2 x squared plus c. And you should be able to verify that by taking the derivative with respect to x of 1/2 times x squared plus that constant, that you do indeed get x to the first, which is the case, because we're going to get 1/2 times 2x plus the derivative of our constant, which is 0, and that is just plain old x. This works for any power. For example, if I told you that x was raised to the 5th power dx, you should get 1/5, 1/6, sorry, 1/6 x to the 6th power, just add 1 to the exponent, plus a constant. Or if I had x to the 2/3 power, yes, it works for non-integers as well. We're going to get 1 over 2/3 plus 1, x to the 2/3 plus 1, and if you remember adding your constants, of course, plus the constant of integration, see, 1 over 2/3, 2/3 plus 1 is equal to 5/3. So we're going to get 3/5 when we do our algebra of x to the 5/3 power plus a constant. And it will even work for negative exponents as long as it's not -1. Right? So, as an example of that, if I wanted to take the integral of x to the -3rd power dx, I would get 1 over -3 plus 1x to the -3 plus 1 and a constant, which is to say -1/2 x to the -2nd power plus a constant. Now there's more rules, of course. All of these rules have to deal with what do we do if we take the power rule. Well, this is the one that we just talked about. But there's also a couple others here that are useful to us. For example, the constant multiple rule. That is, if we already have a constant multiplied in front of a function, then we can take that constant and multiply it by, we're going to get constant times x. So, for example, if I told you that I want to find the constant, the integral of the constant 3 times dx, I know that the result will be 3 times x plus that constant of integration. If I have a constant times a function, then my antiderivative is going to be the constant times the antiderivative of the function that remains after we take out the constant. Let's take a quick look at one of these. If I told you that I had the integral of 5x to the 4th dx, well, that's going to be 5 times, by our integral rule, 1/5 x to the 5th plus the constant, and we see that that is going to simplify to just x to the 5th plus a constant. Finally, the sum and difference rule tells us that we can add or subtract two functions, and we're going to get an integral that is the sum or difference of the antiderivatives of each function. A good example of that is if I have some polynomial that I'm going to integrate. If I said I wanted to integrate x squared plus 5x dx. Well, this rule tells us that I can take the integral of x squared, which is going to be 1/3 x cubed, plus 5 times the integral of x, so that's 5 times 1/2 x squared, and our constant of integration, of course, at the end, and simplify that as 1/3 x cubed plus 5/2 x squared, and a constant. It turns out that there's a whole list of these kinds of rules that go along, and every time you have a derivative rule, there is a corresponding antiderivative rule as well. We've seen that now with our power function. We know that the derivative of a power is x to the n is n times x to the n minus 1. Its antiderivative or integral rule that goes along with it is the integral of x to the n is times dx is 1 over n plus 1 x to the n plus 1 plus a constant. But this goes for the entire list of rules that you have learned in your derivatives. For example, the derivative of sine of x is cosine of x, so it stands to reason that the antiderivative of cosine of x dx is equal to sine of x plus c. The derivative of cosine of x is negative sine of x, so the antiderivative of sine of x times dx would be the negative of cosine of x plus c, just the reverse of what we did when we took our derivative. Derivative of e to the x is e to the x, so the antiderivative of e to the x dx is, you guessed it, e to the x plus c. Again, every single rule that you can think of that has a derivative has a corresponding antiderivative, and you should take time to review those rules.